Hey guys, welcome to another episode, and this time we will be looking at the Lenovo Yoga 7 and what's wrong with the laptop. Well, first of all, there was a mistake in the auction description. So the processor was supposed to be Ryzen 7000 series, Ryzen 7, and instead it's Series 4000 Ryzen 7. So quite a big difference, and I'm hoping for a partial refund from the seller. Visually the laptop looks good. There's a few scratches, minor scratches here on the surface, but well, it's a good quality laptop. It's aluminum, and you can feel it. It's quite premium. Well, then if we open it inside, hope you can see it well. So basically the palm rest look really nice, like really some minor like scratches or dots even and the palm rest looks really like brand new, to be honest. Maybe some dirt on the keyboard, but anyway, it looks almost like new. The same with the screen. I think it looks okay. It should, I mean, it doesn't look damaged at all, so that's a good sign. What you can probably see, there's some physical damage here, like it was scratched or even hit, and there's something similar on the other side. So that's right here. But overall the laptop looks really nice, I think, so it's promising. However, the biggest problem is actually on the other side, because that's how I got the laptop. I mean, this is how it was in the auction, so on that I cannot complain. Apart from the before mentioned processor issue, the rest was advertised like this, so I was fully aware, but you know, I thought the CPU is actually worth it, so I'll give it a try. Well, yeah, it is what it is. I will work on it anyway, and I think there's some like a dent here. You can probably see it's not even here. So yeah, obviously there was some physical damage maybe. Also, you can probably see that there's like remains of the fan here and the screws, but the fan is ripped. That's really weird. I mean, that's not the proper way you disassemble a laptop, right? So well, with that, you know, if it was disassembled like this, I'm a bit worried what damage it got and what condition it is in, but well, let's see together. So what's missing? The heatsink is missing here. I looked it up on the internet, so there was heatsink like here, and there's another fan here missing. Battery, well, I mean SSD obviously as well. There's a Wi-Fi card, so at least that's good. And the back cover obviously is missing as well, so quite a few parts I would need to buy if I want to restore it and then make it fully functional. But I mean, if we can fix it, maybe it's worth it, I don't know. I have quickly inspected the laptop off camera, and well, I measured the resistances, so I will not do that again. Basically it's looking promising, so the resistance on the CPU coils is around 5 ohms, so this seems fine. Also, the resistance on the leg number 8 of the BIOS chip was 18 kilo ohms, so that's nice. And well, I also plugged the power supply, and well, we had 1.8 volt on the BIOS chip, which is good. And the charging voltage, but I'll show you what I discovered. So basically now I think it even changed, so I think it got worse. So basically if I connect the power supply, it's switching. We have 20 volts, if you can see it, so that's good. It means it switches from 5 to 20 volts. It's fine. But then if we measure the voltages on the board, we don't have 1.8 anymore. At least that's what I checked off camera. Yeah, exactly. And it was there before when I measured, so not sure why. Maybe it got worse for some reason, I don't know. But so this is the charging coil, and we have 8.6 volts. That looks reasonable, I would say. But and then we have two coils here, which is probably 3.3 and 5 volts. And if we measure this one, it measures 3.3 fine. But when we measure this one, it measures 3.9, and this is supposed to be 9 volts, 5 volts, sorry. So yeah, definitely there's a problem here. I also checked the on the thermal camera, and this buck converter over here, which is producing 5 volts, should produce 5 volts, is actually getting warm, and this one for 3.3 does not. So those two voltages are essential to actually power up a laptop and produce any other subsequent voltages. By the way, if I open the lid, you can see the fan is spinning for a second, so it looks like it's trying to power up but cannot do that. So yeah, definitely there's an issue here. I will show you that on the thermal camera, and later we'll switch to the microscope. By the way, I've already inspected the board in this area, and I've seen some signs of like a liquid damage, something like white was spilled here. I cleaned that off camera. I will show you under the microscope. There are signs of corrosion. Right, so this is the board under the thermal camera, and here is our 5 volts coil and 3.3 volts. You probably cannot see it that well, but now I'm connecting the power to the board, and look what happens. Something's getting hot. This here as well, but definitely the 5 volt. Okay, two things getting warmer, but we said there's problem with 5 volts and we need to investigate it. And this chip is getting warm, so maybe that's a problem. Okay, so we are under the microscope. Here's our 5 volts coil, and here's our buck converter that we want to investigate here. And as I mentioned, there are signs of corrosion. So even though I cleaned the board, there's like rust on this capacitor right here, over here, a little bit here, but this can probably be fixed. I mean, just put some fresh solder on and this should disappear. Here as well, we can probably save this by just refreshing the solder joint. But here, for example, some of the solder just cracked, and I mean this capacitor needs to be replaced. Even if it's working at the moment, it's probably a point of failure, so it needs to be replaced. Getting back to our buck converter, basically, not sure if you can see it, you probably cannot see it, but let me change the zoom actually, so we can get some focus here, and you should be able to see the marking on the chip, or maybe you cannot. Can you? Okay. Here you can probably see. And if you cannot, I'll just help you. You have to trust me. Let me just get the focus. Okay, so it basically says LJ equals 8A something. The rest doesn't matter. Only two first letters are important. So this is a chip by Richtech. And LJ is basically the marking on the chip which we need to identify. So actually I already identified the chip. Let me get back with the focus. Okay. So actually I identified the chip. Let me show you the datasheet for it. Guess that's the difference between the B and C, and in our case it's 5 volts, so so that's why it's C. It looks like from this. But what's most important for us is the pinout here. So I'll take a screenshot of that and put it on the video under the microscope when I will be checking the voltages. So that you know what we're checking, and I'll make it the same orientation as the chip under the microscope, so it's easy for you to see which pins we are checking. But basically what we need to check is whether there is an input voltage to the chip, so the voltage we want to convert into another voltage. Uh, so that's pin number 5. If then we need to see if the chip itself is powered, that's pin number 9 VCC. And then we should have the enable signal telling the chip that it's okay to work and produce a voltage, basically. And if all those voltages are present, then we should see the voltage on the power good, pin number 7. And also on the pins 2 and 3, which are the output of the chip connecting to the coil. So this is basically the voltage we should see on the coil right here. Yeah, so let's see that under the microscope. And we are back under the microscope and the power supply is connected. So yeah, you can see on the screen the pinout of the chip. So basically we will start with the input power, and this is the pin right here. That's our V in, and it measures 12.3 volt. So that's in the threshold we've seen in the datasheet, and also all those capacitors here, here, and here, and here measure 12.3. So we have the input, and as I said, we should also have the enable signal here, and we have 3.2 volts, so I guess it's fine. And I told you that we need VCC, so the power to the voltage to power the chip, but actually I may have said something wrong. So basically from the datasheet it says it should be 5 volts, and if we measure here it's 1/10, it's 470 millivolts. So it's definitely too low, but it also says that it's not the input, it's not powering the chip, it's the output of the chip that's actually like a control voltage for the for the chip to check if the generated voltage is actually correct. So this is too low, but this may be, I mean, this may be a result of the chip not working properly, so I wouldn't worry about it for now. Uh, but we said that we have input voltage and we have the enable signal. Let's check if we have power good signal, but I assume we won't. And that's correct, we have 0 volts here, and that's expected. And also, as I said, the output will be here, and as mentioned it's 3.9, so it should be 5 volts. It's definitely too low. And since the chip is getting hot and we have the input voltage, we have the enable signal, but we have incorrect voltage on the output, and also this control voltage is too low, then I believe we need to replace this chip, and I happen to just bought one, so I have a new chip to replace. Let's do that together and we'll see if it's any better. Okay, so the new 5-volt chip is actually soldered on. That's our 3.3 volts coil, and this is 5 volts. Yeah, let's power it on. Let's connect the power supply and see if it's any better. I mean, I'm not gonna check all the single voltages, let's just check the output voltage. If it's correct, then it's correct. And yeah, so right now there's no power draw, I mean very minimal, like 0.0.024 of an amp. So 24 milliamps basically. Let's check. So 3.3 volts, we have 3.3. The charging coil is 9.2, that's nice. And 5.1, that's perfect, we have 5 volts. So with that, let me take the multimeter out. Let's try to power it on and see what it does. I will put a heatsink on just in case it turns on. I don't want any damage. Not sure if you could see, if you will be able to see the reading on the meter. Alright, let's move it a little bit like this. I'll hold the heatsink like so. I don't want it to fall down and short anything. And let's try to power on the laptop. Oh! Okay, that was quick. It's actually on. It says no boot device basically. Okay, that's fast, that's quick. Okay, so I guess we have a fix. I cannot check it further because I don't have like half of the parts for it. The power draw is around 1 amp actually, so around 19 watts at the moment, and we are like in the BIOS screen basically. I'll switch it off now because it's getting hot. Okay. So yeah, I guess that's the end of it. As you can see, I have the laptop fully assembled. I have bought the heatsink separately, this fan, and the back cover in one auction. I mean, separate auctions, but from the same seller. They obviously had some spare parts from this laptop. I also bought a replacement battery from China, so it's not original, but it has the same capacity and it's working very well. And at the very end I noticed there are speakers also missing, so I bought them too, but instead of buying them on the auction where it costed like $25, that was the cheapest price for just the speakers, I bought like entire palm rest, so this bottom part here with motherboard and the heatsink I think, and the speakers. So basically I paid like $7 or $8 more for that, and I got the entire palm rest, and you can expect a video about that one, and then the motherboard I bought with shortly. So that's gonna be on the channel, but for now, as you can see, it's fully assembled. I haven't put the back cover on because I may change the hard drive, the SSD, so I'll just cover the back cover on and do some testing so that you can see the laptop is working. Alright, and we are in Windows, and I've run Cinebench R20, and the score is exactly 3000 points, so that's quite good, I would say. Really nice, decent score, and the laptop is super snappy, works very well. Also, right now it's on battery, and it says the battery is 99% full. It says over 6 hours of battery life, so that's good. And if we connect the power cable, it's also charging without any problem. The charging symbol is now, and
I just charged the battery to 99%, so I know it's working. What else? All the devices in the device manager are installed, so no problems here. Wi-Fi is working, and you can see the video playback. It's also battery smooth. So as you can see, everything is working perfectly fine. Probably the only downside for me is the Scandinavian keyboard, but it is what it is. But overall, it's really nice laptop. It has some like scratches here and there, but like the palm rest looks really good, and well, it feels premium, I would say. So I really like this laptop. Thank you for watching, leave a like if you enjoyed the video, subscribe to the channel if you haven't done so already, and see you in the next one.